Okay, so section 5.2 is all about angles. And I said in the introduction that an angle is a measure of rotation for how far around a circle we've gone. And so if we think about that horizontal line that I just drew as the positive x-axis, because that's usually where we're going to be starting from. And then if we rotate around our circle part way, and we draw another line, this measure is the angle. And so we started from this side, from the positive x-axis, so we call this the initial side. And the place where we end is the terminal side. Now, we're going to start with degrees, and 1 degree is 1/360th of a circle. Because I'm pretty sure we all know that 360 degrees is 1 full rotation of a circle. So I said a minute ago that we were going to usually start from the x-axis. When we start from the x-axis, that is called standard position. So an angle in standard position is one that starts at the x-axis and rotates counterclockwise. And so counterclockwise is going to be our positive direction. But we can also, there's no rule that says we can't rotate negative or clockwise, and we're going to call that a negative rotation. So, for example, let me do it this way. If I draw a circle, and I'm just centering my circle in the origin, this okay, well, we won't let it fix it for me. This line is approximately a 30-degree rotation. This one is negative 30 degrees. Okay. Now, we're going to use Greek letters in this class to signify angles a lot. So just so you have a language, this symbol is theta. This, or this, is phi. We're going to use alpha an awful lot. We'll also use beta. And occasionally we'll use gamma. I give you the names of these symbols so that you have something to call them other than the zero with the line through it, right? It just makes it easier. Okay, so now we know that we can get to the same point on a circle different ways. So let's think about this circle again. Whoops. Okay. And let's say I want to get to this spot right here. There's a couple of different ways I can get there. I can take the short way and stop, right? But what else could I do? Well, I could be contrary and go backwards. Yes? I could also go the really long way and go past it. and come back. And you can see that there's really an infinite number of combinations here. All three of these angles, if I label them alpha and beta and gamma, because we started from the positive x-axis in all cases, and we ended up at the same point, alpha, beta, and gamma are said to be coterminal angles. So let's just say for grins and giggles that this is a 45-degree angle. Okay? How would I figure out what beta is? Well, if we think about what I did, I went not quite all the way around. So we could think about going all the way around and then backing up. So what this is, so beta would be, it's a negative. So it's not negative 45 because I didn't go 45 degrees. I went 45 minus 360 degrees is 315. So that's a negative 315 degrees. Gamma, think about what I did. I went my 45 degrees and then I went a whole nother 360. So that would be 360 plus 45 degrees, which would be 405 degrees. Now, whether I go 45 degrees, 405 degrees, or negative 315 degrees, I still end up in the same spot on my circle. Those are all coterminal angles. Okay, all of this leads us to what we call the unit circle. And a unit circle is nothing more than a circle with radius 1 centered at the origin. Now, the reason why this circle is special is because it's got some standard angles marked on it. So these are angles that are multiples of 30 degrees, 45 degrees, 60 degrees, or 90 degrees. So here we've got 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and of course 0. Those are all multiples of 30 degrees. And it turns out that 30 and 60 degree triangles, right triangles, are really important in construction, and they form a very stable geometric shape. And so that's why we talked about 30, 60, 90 right triangles in earlier courses. And we know there's some special things about those, and we'll talk about that again later. We also have on here multiples of 45 degrees. And 45 degrees, 45 degrees is special because the x and y coordinates at your 45 degree points are equal. Equal in magnitude, not always equal in sign. This is one of those things, this is called the unit circle. We will be adding to this as we move through this chapter. It's centered on the origin and has a radius of 1. Okay. I'm going to stop this recording here, and when I come back, we will talk about our other measure of angles, radians.